Question 12. The value of a car decreases by the same amount every year. The following table of values represents the function which associates the number of years since the car's purchase and the value of the car. So we have number of years, 2, the value is 16,800, and then at 5 years, the value of the car is 6,000. So first of all, I want to know the rate of change for the situation. So rate of change, delta y over delta x. So I'm looking at the two y values. So I'm going to do 6,000 minus 16,800 divided by 5 minus 2 divided by the delta x. And that gives me 10,800 divided by 3, which divided gives me negative 3,600. Okay, so that means, so that's the rate of change. That means that the value of the car is decreasing by 3,600 a year. Okay, so every single year it drops 3,600. What's the car's initial value? All right, so what I'm going to do is, I know that it's dropping this amount every year, right? It's dropping 3,600 every year, and its value after 2 years is 16,800. So I'm going to multiply 2 times the 3,600 because of the 2 years that's gone by, and then we'll get its final value, or its initial value of $24,000. Okay, so that's the initial value. So the rule for the function, remember, it's y equals ax plus b, right? The a is the rate of change, which we already know is negative 3,600, negative 3,600 times x plus the initial value, 24,000. All right, now they want to know what will the car's value be after 4 years. So I'm going to say that y is equal to, and I just use the function, I just replace the x with 4. So negative 3,600 times 4 plus 24,000 is $9,600 after 4 years. Okay, whoops, and then after how many years will the car's value be equal to 15,000? All right, for it to be equal to 15,000, I'm setting the y value to be 15,000 because the y value is the money value. And so then we have the rest of the equation, negative 3,600x plus 24,000. And so I'm just solving for x. So I subtract 24,000 from both sides. That gives me negative 9,000 is equal to negative 3,600 x. I divide both sides by negative 3,600, and that gives me 2.5 is equal to x. Okay, so after 2.5 years. Okay, that's that answer. And this is after 2.5 years. After how many years will the car's value be equal to $2,400? So I'm going to do the same thing. So set the y value to 2,400 and solve for x. So I'm going to subtract 24,000 from both sides. That gives me, okay, that's supposed to be negative 21,600 is equal to negative 3,600x. Divide both sides by negative 3,600, and that gives me 6. So after 6 years, it's equal to 2,400. Okay, or 6 years. How long will it take for the car to be worthless? Okay, so when is it 0? So I'm going to set up the same equation and make the y value 0. So I'm going to subtract 24,000 from both sides. That gives me negative 24,000 is equal to negative 3,600. Divide both sides by negative 3,600 to get the x alone. And that gives me 6.6 repeating. Okay, or 6 2/3 if you like. So after 6 2/3 years, or, well, 2/3 of 12 months is 8 months. So 6 years, 8 months. And then they want the intervals for the independent. Now the independent is the number of years, right? So we start at 0 years, okay, when it's brand new, and we go all the way up to 6 years, 6 2/3 years. So I'm just going to write it like this in an interval. All right, for the dependent function, for the money, okay, the money starts off at 24,000 and then goes all the way down to 0, but I'm just going to write it in the proper order. I'm going to go 0 to 24,000. As the years increase, does the value of the car increase or decrease? It decreases, and then draw a graph of the situation. So the initial value is 24,000. Well, here's all the different number values. So there's my 24,000, and then, yeah, whoops. Then at 6 2/3, we know the value is 0, so I just connect the dots. There's your graph. All right, and that is it for number 12. Have a good night.